Hello and welcome back to Mikey's Flightdeck. Today I will show you how you can create a small test setup that connects a hardware like this switch via an Arduino to Prosim. What am I doing here? As I already said in my last live stream, Prosim is supporting the channel with a license of their 737 suite. So I can show you the steps you have to go when you want to integrate such a system to your hardware. And I hope I can reduce the fear of getting in touch with the software. Before we dive into the installation and settings in Prosim, let's discuss the question, why should I need a dedicated simulation suite? I already have prepared and the PMDG 737 installed, so why should I invest money into another system? One point could be the performance. You can often read the discussion that the PMDG needs a lot of system resources. And this is because the add-on has to calculate the simulation of the Boeing system logic, as well as the presentation of the virtual cockpit and all the possibilities you have with it. The only task of the simulation suite is the simulation of the system logic. And in most cases, it does the job without the need of the presentation of cool panels because you have them in reality in your cockpit. You can also let it run on a different computer so that your main computer can concentrate on the presentation of the scenery. Another part is the presentation of different displays. In the PMDG, you have to undock the displays, the ECAS or PFD, for example, to show it on a different monitor which is connected to your PC. But with a suite, in most cases, the display is a separate application that can be started on a different PC that can communicate with your main computer. So again, you can transfer workload from your main PC. And now let's have a look into the components of Prosim737. The suite is divided into several modules. Prosim System manages the simulation of the aircraft systems and acts as a hub for all the other modules. Prosim MCP simulates the autoflight system and the EFS functionality and comes with a graphical panel that you can show in your cockpit or use for testing purposes. Prosim Display generates all the graphical elements like the primary flight display or navigation display, which you can show on different monitors in your cockpit. These can also be monitors that are connected to other computers in your network. As long as the display module is running on that computer, the graphic can be shown. The CDU module controls the flight management system and gives you the possibility to show a complete CDU on a monitor to control it with a touchscreen, or only the display signal, which can be shown on many devices of third-party developers. Prosim Panel shows all the different cockpit panels that can be used instead of real panel hardware or just for testing purposes. With Prosim Sounds, you have access to a library of sounds you can play during special cockpit events or integrate your own cockpit sounds. You don't need to use one of the simulator planes for your cockpit because the software comes with its own flight model. And you have access to a full instructor station, which is accessible via a web interface. You will be able to connect hardware of many manufacturers via different ways, whether you connect your hardware via USB and a COX script or via Ethernet. And now join me when I will take my first steps into the setup that will transfer the signals of my hardware from an Arduino via Ethernet via an IOCP server to Prosim. I want to give you an overview what will technically go on now. I will connect a switch and a LED to my Arduino with a connected Ethernet shield. This will communicate via Ethernet with the Homecockpit's IOCP server, which will forward all signals to Prosim. So, what is an IOCP server? It is a program that gives a client the possibility to get informed about the value changes of variables from other clients and also to inform other clients about values of their own variables. Let's make an example. For the auto throttle light in the Prosim MCP, I assigned the variable number 14. My Arduino will register this variable number on the IOCP server so that he will receive informations about changes. Now, every time when the state of the variable changes, the MCP module will send the new value to the IOCP server. And because the server knows that the Arduino is interested in it, he will forward the new value to the Arduino. The advantage is that the Arduino isn't informed about the state of every variable in the cockpit, but only about those that are necessary for his work. So enough now about the theory, let's go to work. First of all, we will test the communication between the IOCP server and the Prosim software. And for this we'll have to download some software, and you can find the IOCP server on the Homecockpit site under Downloads, and there in the CIOC category, and there you will find the CIOC package which you can download and install. The Prosim software can be downloaded from their website. Also under Downloads, download Prosim737, and then you can choose from an archive file or an installer. You can download and use the software where the only limitation is that it only runs 30 minutes and then you have to restart the software. After installing the software, I will start my IOCP server, which is Homecockpit CIOC. And the server is started automatically when the software is running, and you can see it is hosted under the IP address of my computer, which is also the local host when I'm connecting on this machine, and the port is 8092. These values we'll need when we start Prosim now, and you start with the Prosim737 system module. In the system module, we'll configure our started IOCP server under Config and Configuration, and then go to the Drivers tab. Here you can find all the entries for all other third-party developers. And here we also have a field IOCP server, and there I will enter my IP address. I think I also can write localhost and the port. When we say OK, Prosim will have to restart. Now we will start the MCP module, and to control if everything can communicate with each other, you can right-click on the MCP module, and under Status you can see the server connection is OK, and that is all we need now for this test. What I want to control in this test is the auto throttle switch and later the auto throttle indicator. And we will start with the switch. And we'll assign a variable for this switch now. And this you can do in the system module under Config, Configuration, and Combined Config. And there you can see the different parts of the cockpit and your panels you can access. And we are in need for the throttle and MCP category. This is again divided into several categories, and we'll need the switches category. And searching for the auto throttle switch. You can find the switch here under the name MCP AT ARM. There are two states of the switch, ARM and off, but you will only need to communicate with one of the states, because when the switch isn't armed, it is logically off. So I will only concentrate on the ARM state here and choose the IOCP server. And now I will have to assign a number for this variable. Let's name this 15. You can choose any number you want. I think there are some numbers that are reserved for other parts of the panels, but I think this you will find out. By the way, you now can see that there is another client connected to the IOCP server, which is the MCP panel. Now we need a way to control the traffic and the communication between the server and the connected clients. And this you can do with the IOCP console. There are some variables already assigned and we don't need them, and to get rid of them we close the console and say empty script. Now everything is clean here. Now we want to simulate our first command that can come from any connected client to the IOCP server, for example the Arduino. We will turn on the logging here. And now let's send for the variable number 15 the value of 1 and send it, and look at the switch here. It's going on. And when we send a 0, it's going off. That's it. You can also assign names to this variable. For example, MCP auto throttle, and say accept. And now for the variable number 15, this name is assigned here, and you can save this file when you want to have it for later import or later tests. So that already concludes the first test of sending variables from the IOCP server to Prosim. And now let's make a simulation that we listen to one variable, and this will be the indicator of the auto throttle arm. So for this purpose, I will go back to the system module, again to the configuration, combined configuration, and to the throttle MCP category, and this time to the indicator category. And there we already have the MCP auto throttle indicator, and we also say IOCP and assign a number, let's say 14. And here you can already see in our logging that the value of 0 is sent for the state of the indicator here. And you can see it is off, so the state of 0 is right. And now if we assign a value of 1 for the variable number 15, which means we switch the auto throttle switch to ARM, then you can see 1 for variable 15 is sent, and we get an answer from the MCP panel, which means that for the variable number 14, the state is 1, which means the light is on now. And you can see the light is on. And with this information for the variable number 14, we can make something in the program on our Arduino that will react on this on state and set a corresponding hardware light on. And this is what we have to do now, and we'll now face the programming part for the Arduino. Now let me describe the hardware component I will be using. For this project I'm using an Arduino Uno and a breadboard to hold all the components. I will mount an Ethernet shield on top of the Arduino and connect this via an Ethernet cable with my switch, and this is connected with my computer. The Arduino will be connected via USB with my PC for uploading the scripts and testing some serial communication. I will connect a LED light to ground and via a resistor to pin 2. And the switch will be also connected to ground and pin 3. And this is all what you need for this first setup. To start programming with the Arduino, you need the corresponding IDE, which is a software package that makes your computer possible to program for the Arduino and communicate with it and upload the sketches, which are your programmed scripts, to the Arduino. And you can find it on their website under software and downloads. And here you can download the actual IDE for your system. What you will get is a package with all the classes that you need to program the software, and also this little editor here where you can write your scripts and upload them to the connected Arduino. But I'm preferring a little bit more powerful editor here, and this is also free to use, and it is the Atmel Studio, which you can download actually in the version 7 from their website here and install it. And in combination with another plugin, which is called Arduino for Visual Studio, you can write your scripts very fast and easy, and with the support of the software. In Atmel Studio, you should ensure that the right Arduino IDE is selected here, and the Arduino you have connected to your PC, and also the port where it is connected to. If this is all right, then we can start a new Arduino project. There's already a basic code structure made by the program, and I'm now going through the programming steps very detailed. So if you are already familiar with Arduino programming, then this might be a little bit boring for you, but I want to reach as many of you as I can here with this project. First of all, we'll have to add some libraries, which we be using later. And this will be the SPI and the Ethernet library. Now we'll define some global variables, and first of all a MAC address. I've copied this MAC address from my clipboard because I didn't want to type it in here. This MAC address is for identifying your Arduino in your network, and you will need the IP address of the IOCP server. Then we will need an Ethernet client, which we will use to communicate with the network. And all the characters that we read from this Ethernet connection, we will store in a character just named C. All these characters will later be written into an answer string. And as you know, we will receive variable numbers and values that will be stored also in separate variables. First of all, the number and the value. The state of our switch will be stored in a separate variable. And we define the 2 pins of the Arduino we'll be using. And this will be the pin for the switch, which is on pin 3, and the LED pin, which is pin 2. As the name says, in the setup function, we'll set up everything which will be needed when our Arduino starts the first time or is resetted. We define our switch pin as an input switch with a pin mode command. And we will define this as an input with an intern pull-up resistor. And this is to prevent the switch from being disturbed by any electric noise or something like this. So you will have a clean signal when it is connected there. And our LED pin, we define as an output pin. To control some values in our serial monitor, we'll start a serial connection. And this is the connection via the USB cable, and the output will later be in our serial monitor. And now we already start the Ethernet connection and give the command the MAC address. Now our first serial output will be connecting, so that we can see that the connection is starting. Now we make the connection to the IOCP server, and this we have to do in an if state so that we can react if anything goes wrong. With our client object, we try to connect to the IOCP server, which we have defined up here, and with a port. You can enter the port number here, or you can define it as a variable up here. If the connection was successful, then we will make an output on our serial monitor and then register our needed variable at the IOCP server. This we will do again with the client variable. And this is the first Coq special command. When you want to register variables, then you start this with the arn.initio command, and with this double point separated, you can register as many variables as you want to. If you want to register more, then you can say 14 and 16 and 17 and so on. But now for the test, we are only in need for number 14, which is the indicator of the auto throttle switch. If something went wrong, then we make again an output. The last thing we have to do is to initial set our switch state, and this we do with a digital read from the switch pin. And this concludes all we have to do in the setup function. The loop function is called many times a second while the Arduino is powered on. And here we will check from time to time if we are still connected to the IOCP server. This we can do with the client object. So if the client is still connected, then everything is okay. But if it is not connected, then we have to reconnect to the server. And first of all, we will stop the client then, just to be sure, and wait a second. And then we can start a new connection. And this is the first time we can modify our code, because we have to do everything we have done here from Ethernet begin. And every time you can reuse code here, then do it in a special function. So your code will be more flexible and easier to maintain. So I will make a connect function and copy all this code here into it. And in our setup function, we will call to this function. So you see, this is much more readable here. So after the delay, we again call this function. Now we come to read in our first characters. And this we'll do in a while command. So while there is anything available at the client, we will read everything we can get into our C# and append this to our answer string. So let's make our first test if there is anything that we can receive at the moment. And this we will test only if the answer string isn't empty. And if there is something in the answer string, then we will print this out. After we have printed the string, we will empty it again. And now we already can test this code we have written here. So we compile and upload it to the Arduino and then start the serial monitor. So we have received already something. You can see the connecting and the connected. So we are connected to the IOCP server. And after we have sent our onInitio command, the server has answered with onVivo and already sent us the first state of the indicator with 1, which means the LED is on. Let's see if this is right. And there it is. It is a green LED. Now if we switch this off, you can see we receive a 0 because the LED is off. So let's try now if we can send commands with our switch to the MCP module. We will need a function that will check the state of the switch and then send the corresponding command to the MCP module. This will be a set switch function, and it will check the switch state. If the switch state is low, which means the switch is on because we have, when you remember, the pull-up resistor here, and this means when there is a low signal on the port, then the switch is on. So when the switch is on, then the client sends a command, and this is also IOCP or Opencockpit's COG special. It will send onResp for response. 15 is on. And otherwise, we send an off signal. But we are working here with a switch state variable, and we have to update this variable from time to time. And this we will do in an update function, which we call update switch. And in this function, we will check if the switch state is a different state than the current state on the pin. So we read the signal at the pin, and if this is another one than the one we have stored already, then the switch has been changed. And so we have to update the switch state and restore the new switch state. And after the new value is stored, then we set the switches again. So this update switch function has to be called from time to time. So we will set this here in our loop function. But we don't only want the switches to be changed when we switch them. We want to be the MCP module in the right switch state already when we start up our Arduino. And so we will have to initialize the switch state so that the function looks what is the state of our switches and set this already at the beginning to the MCP module. And this we will do here in our processing of the string answer. And we will check if the string answer contains the onVivo response. If the index of onVivo isn't -1, then there must be an onVivo in the answer string. And this will only be at the first answer of our IOCP server. So we can use this point as the initialization of our switches. And so we can here call the setSwitch function. to send the first state of our switches to the server. So let's test the program now. We are connected again and we have an off signal for the indicator. That's right. So let's test the code for the first time. We are connected and have received the off signal. And this is right, the indicator is off. And now let's use the switch for the first time. And you can see the switch has gone to ARM and the indicator is on. And switch this off. And the switch goes off. We can now send commands via the switch to the server and we can receive the state of the indicator. Now the last thing we have to do is to show this indicator state with the LED on our breadboard. So we will have to go through the string and search for these 14 equals 0 or 14 equals 1 signs. And these we have to bring to a command to the LED. Before we work with the string, we will remove any garbage signs from the beginning or the end of it. And this we can do with the trim command. After that, we'll get rid of everything we don't need in this answer string. For example, this whole on rest part here in front of the 14. And this we will do in a special trim function. So I will call this trim answer. And with this function, I will remove everything in front and including this first double point here. So we will use the remove command. And you can see here in the help, we will need a starting index and the number of signs we want to remove. The starting index will be the beginning of the string. And how long will we remove this? Well, until we find this resp double point. So we will search for this in the string. You know this command already from our initialization. So it will search in the string for the resp double point sign, and then it will go 1, 2, 3, 4, 5 characters forward to remove this also. So after this command, there should be only left 14 equals 0. And we will call this command here at this point. Before we can test this, we will add another serial output here right after the trim command. And we will write the string answer again, so we can see how this has changed. And here we can see, before the trimming, the string was vivo unresp 14 equals 0, and after this, it is 14 equals 0. And when I switch my switch here, then you can see it will be reduced to this answer here. Now we will have to get the separate values from this remaining string, the 14 and the 0, for example. And this we will do with another special function, which we will call extract next value. So this function will return an integer value, which will be the value of the variable or the value itself. And I will give a delimiter into this function, and this will be the equal sign or this double point here. So as I said, it will return a value. And now we have to get something into this value, and we will do this from the answer string, and we will cut out a substring from it. And you can see again, the substring command uses a beginning index and the end index. The beginning index will be the beginning of the string because it already begins with a variable number which we want to have. And which will be the AND index? Well, this will be the index of the equal sign. So we have to search for it. You know this command already. We are searching for the index of the delimiter, which will be our equal sign. And the string we read with the substring command, we will convert to an integer. After we have the substring, we will remove the variable number and the equal sign from the string. And you know this command already, from the beginning up to the equal sign. Additional 1 to remove the equal sign as well. Now we can use this extract next value function, and we will do this here. And we should only do this if we have anything left in the answer string. So again, we are asking if the string isn't empty. Now we will read the values, which will be the number of the variable, next value, and our delimiter will be the equal sign in the first run, and the value we will extract until the double point. So let's print these two variables out for testing and test this code. So here we have it. We received unresp 14 equals 0, and this was made to 14 equals 0, and the two variables 14 and the value of 0. And when we switch the switch, then we get 14 equals 1 and the corresponding values. You can see here we get two zeros, and I think this must be some errors in the initialization here. And to get rid of this output and don't run into any troubles while we set the indicator, we will set the indicator only when the variable number isn't 0. So this we will do here. If the variable number isn't 0, then we will call another function which will set our indicators. And this function we will do now. We will call this set indicators, and we will look to our variable number. And if the variable number is 14, which is the number of our auto throttle indicator, then we will do a digital write on our LED pin and set this pin to the variable value, which will be 1 or 0, which means on or off. So here in this switch case, you can add more and more variables and other indicators you want to check. And every time the variable number is set, then the set indicators will be called and the next variable will be set. So now we have to call the set indicators function here only if the variable number is not 0. So let's test this code. We'll open our serial monitor and the MCP. We have received a 0, which means the indicator light is off, and you can see this too at the LED here. Now let's get on the switch, and the LED is on, and also the LED on our breadboard, and off again. So everything is programmed now, and we are ready for the last ultimate test. I have disconnected the Arduino from the PC and used the USB cable just to provide power via this USB power supply here. So the Arduino is disconnected physically from the PC, and I will set a switch state which will differ from the state in the Prosim737 module. So we can test if this hardware will be connected to a running simulator system, if our set indicator and initialize switch functions will work. So the Arduino is still disconnected. You can see the auto throttle switch on the Prosim737 module is off. I will set this switch here to on. so that it differs from the state that is set in the Prosim module. Now I will provide power to it. And the LED goes on, and also the LED in the MCP module. And we're already connected, and now when I switch it off, the LED physically and in the module goes off and on again. And so everything worked as it should be. Wow, what a coding session. I hope you could follow me along, and if not, you can play back the video and watch the parts again you have missed. Remember, this is just an example code and it can be modified in many ways. I think we'll do this in an upcoming video. You can add a header file, for example, so that you don't have to deal with this mysterious numbers like 14 for the auto throttle indicator. There will be many more we have to discover, like 7-segment displays, rotary encoders. We will add port expanders so that we can increase the number of ports we have available on our Arduino. But this all will take place in an upcoming video. So I want to say thank you to Honecockpit from Prosim for making me available a license for this software. And if you haven't done already, then subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see us soon back on the flight deck.